Hello, everyone. Welcome to another ACT prep session. Today, as usual, we're going to pick up where we left off. Yep. So, last time we were working, we were talking about interpreting word problems and how different parts of an equation can mean different things. In this case, these are other examples that don't necessarily require a whole lot of math work, just maybe reorganization, simplification, and common sense. So these two thought problems, let's go through them. Oh, whoops, we're not doing geometry just yet. All right. So question number one. A gas in a container will escape through holes of microscopic size as long as the holes. Okay, you know what? When it comes to word problems, a lot of times the first few sentences are going to matter if they're giving word context that doesn't really affect the question. So you can just skip that. Usually you should just look at the mathematical equation first. So R1 over R2 is equal to the square root of M2 over M1. This is a chemistry thing. Okay, at the bottom, which of the following correctly expresses M2 in terms of M1, R1, and R2? So basically, when they say express something in terms of something else, they mean don't use numbers to find the value of this variable, but use simplifications. You can isolate the variable in question and then see how it relates to the other variables, like how in the option choices you see here, M2 is on one side and all the other variables are on the other side. Honestly, yeah, this should be pretty simple. First order of business, if we're trying to find M2 over here, issue is that since it's caught in the square root, right? So why don't we square the whole thing? So if we square the whole thing, just wanted to let you guys know, oftentimes in math, you're gonna have variables that have a subscript at the bottom. So for example, this R1 has like a 1 underneath it, and then there's a 2 underneath it. That does not correspond to any numerical value, or it doesn't mean anything in terms of mathematical functions. It's just an identification. So be careful about confusing exponents and subscripts. But yeah, as I was saying, so if we square the whole thing, we end up with R1 squared over R2 squared is equal to M2 over M1. And okay, we want to find M2. Okay, then simply multiply the whole thing by M1. And we're left with M2 is equal to M1 times R1 squared over R2 squared. And obviously D is going to be incorrect and C is going to be incorrect because they kept the square root. But then B and A, that might seem really similar at first, but then realize they have a 1 subscript at the top in A, and then they have a 2 subscript at the top in B. So the correct answer is going to be A because it has the correct subscript at the top. Because remember, the 1 is supposed to be up there. That's what I meant by be careful about confusing exponents and subscripts, because even me, if you look at those two answers, it might seem virtually the same. And if your brain's racing really quickly, then you might not notice things like that. Oh, this is going to connect to the 3 types of quadratic equations we learned last time. Okay, the store manager, okay, basically the store manager is trying to sell video games and he's selling them at a price of P dollars, and then RP represents revenue, and this is the equation that represents how much revenue he gets depending on how much money he sells video games for. Which of the following equivalent forms of R to the function P shows as constants or coefficients the maximum possible weekly revenue? The maximum possible weekly revenue. Okay, so first thing, we know this represents weekly revenue. If they want to find the maximum piece possible weekly revenue, we have to find the value of P where R of P is at its max. And the thing is that this is a quadratic equation because it has the P squared, right? And since the coefficient for the quadratic term P squared is negative, then we know that when we draw our quadratic equation, it's going to be flipped upside down, like an upside down U. Oh yeah, that's a quick thing in quadratic equations. In terms of ax squared plus bx plus c, if a is negative, then it's going to be an upside down kind of structure. If a is greater than zero positive, it's going to be like a cup, like a U shape. Okay, but yeah, back to this. The maximum, where's the maximum going to be located? It's going to be located at the vertex, right? The vertex is like the most extreme point, the point with either the most negative y value or the most positive y value. In this case, it's going to be positive because it's a negative quadratic equation. So it's going to be like a hill with the highest point. So, okay, they're asking which of the following forms represent the maximum value. And remember the keyword vertex you just mentioned? What are the three forms of quadratic equations we learned about? We have standard form, ax squared plus bx plus c. It's a good old fashioned, but not very useful, honestly. We have x-intercept form. Sorry, yeah, we have intercept form, which is x minus h times x minus q. I'm pretty sure I use different letters, but it's okay. Basically, these represent like x-intercepts, and then we have vertex form. Y is equal to a times x minus h squared plus k. Again, I'm pretty sure I use different variable letters, but you should get the same general idea. This is vertex form, right? So anything written in this form will provide you with the vertex of the quadratic equation. Which of the following is in vertex form? A, that's in standard form, so it's not that. B, they factored it out a little bit, but they didn't they didn't factor out the p values, and yeah, it just looked kind of unfinished, so B is not going to be the right answer. C, both of the terms have p in it. Ideally, with vertex form, you want only there to be one term, or actually you want the term to be in a squared form where, it's something like x minus h squared. The above one over here, it's like x squared minus ax something. That's not really helpful for finding the vertex. The only option left is D, and clearly that is in vertex form. You have your initial coefficient, you have your squared x term, and then you have your y value of the intercept. Okay, so now we're going to move into geometry. This can be either fun or it can be kind of annoying. We'll see how it goes. Okay, the first thing we're going to start with, we are going to start with parallel lines and how angles relate when it comes to parallel lines. So imagine we have two parallel lines. A way that they represent parallel lines is by drawing these horizontal lines through them. If you see two lines that look like they're parallel and they have two small marks going through them, that means that those two lines specifically are parallel, and they can have multiple marks. As long as they have the same amount of marks, that means that they're parallel. If you see a line that's kind of parallel, but not really. Just imagine that this looks somewhat parallel, but it has only one tick mark. Since these have two tick marks and this only has one tick mark, the question is telling you that the line with one tick mark is not parallel to the other two. Just wanted to clear that up. So yeah, imagine these two lines are parallel and we have another straight line that cuts right through the parallel lines, as you can see in this equation. When that happens, a whole lot of angles are created, and these angles have pretty special properties. So, okay, the first one we'll talk about is, I think we'll talk about corresponding angles first. So, okay, if you look at this, you notice how each angle is sort of like in its own sector. There's like four sectors. The way I like to think of corresponding angles is that angles in the same sector have equal values. They are congruent. They have the same angle measurements. So an example of that would be, angle 6 would be equal to angle 2 in terms of how big it is, because they are corresponding angles. They're in like they're in like the top right of the intersection that was formed. Someone put in the chat that they might use different marks instead of lines to represent parallel lines. Yeah, that's actually true. I believe it is pretty common as well to use like arrow marks like this, so keep that in mind as well. But yeah, thanks for bringing that up. Anyway, other thing, sorry, my throat's a little bit, stuffy. But yeah, so angle 2 and 6 are congruent to each other because they are corresponding. And in that same way, um, angles 1 and 5 are congruent to each other. And we can, keep going, like angles 8 and 4 are congruent to each other, and angles 7 and 3 are congruent to each other. Now, okay, let's take a step back. That one was a little bit, intuitive. Corresponding angles that are in like the same area where they were cut will be congruent. Now, another one is opposite angles, where when you form an intersection between two lines, let's say this is angle X and then this is angle Y, these two angles are considered opposite angles because directionally they are exactly opposite of each other. And also it's considered opposite because these angles are formed by the two lines. Any angles that are formed by the same two lines are going to be opposite. And the thing about opposite angles is that they are congruent to each other. So angle X is congruent to angle Y. Now, some examples in the graph we have above are angle 7 is congruent to angle 6, and angle 1 would be congruent to angle 4. Okay, now the next one, which is seems a little bit arbitrary, but is pretty important, is alternate interior angles. So the two words here, alternate interior, mean different things. Interior means within the two parallel lines, and alternate means on different sides of the intersection line. This is this doesn't have like a common name. I'm pretty sure it does. For now, we're just gonna call it the intersection line. But yeah, alternate means on different sides of the intersection line. So what is an angle that is interior? Let's take angle 3, for example. And then, okay, what's another angle? Okay, we have two angles, 5 and 6, that are both interior. And then alternate, 6 is going to be alternate to 3 because they're on different sides of the intersection line. So 6 is going to be congruent to 3. And in that same way, you can say 5 is going to be congruent to 4. Oh, some people in the comments said that this is called the transversal. Transversal, thank you very much. Yeah, but yeah, so that's an example of alternate interior angles. Now I don't know why they don't want to like teach kids this, but the same applies to exterior angles, where if you have two angles that are exterior, like 7 and 2, and they're alternate, they are also congruent to each other. It's not as helpful typically because they're probably not going to make as many questions on that, but I just thought it would be something you guys should know. Oh, another one that is important is same side angles. Ignore the interior part. Same side angles are supplementary, and supplementary means that they add up to 180 degrees. Now, if you just take like a line, right? There's a point here. Imagine that this represents an angle. A straight line angle is going to be 180 degrees, right? Obviously. So if you have two angles that are on the same side that are attached to the same transversal, they're going to be supplementary to each other. I'll provide an example. Let's take 3. It's on the same side as 4, and they are on the same side of the parallel line. They're on the inside of the parallel line, and they are right next to each other. These two angles are supplementary, meaning if you do angle 3 plus angle 4, it'll equal to 180 degrees. Now you might be thinking, how is that helpful? Well, if you know the value of, let's say, angle 3, and you know that 3 plus 4, angle 3 plus angle 4 is equal to 180, then you can subtract angle 3 from 180 and you'll be able to find angle 4. Simple as that. So, okay, let's put this to some actual use. So, okay, before we move on, I want to explain another thing, the Pythagorean theorem. This is something super duper important in the world of triangles. If you have a right triangle, like, you know what, let's just use the above example, like ignore this, or, you know, actually, since it's upside down, I'll just make my own triangle. If you have a right triangle, and imagine that the hypotenuse is the side that is the longest in a triangle and also faces the right angle. If you imagine that the hypotenuse has a value, side length of C, and the other two angles have a side length of A and B, then A squared plus B squared is equal to C squared. Very useful theorem. I'm sure that most of you already know this. But yeah, it's going to be important for this question. Now, I am actually going to try and give you guys, let's see, 2 minutes to think through the problem and see if you can come to any idea on how to move past it. You don't have to necessarily solve it. Yeah, so 2 minutes starting now. I'm going to let you guys think about it. All right, everybody, 2 minutes are up. Let's come back. All right, I'm gonna assume this question melted like at least 50% of y'all guys' brains, because this is a pretty difficult question. These questions are pretty rare on the ACT. They typically won't give you something that takes this much effort, but if you notice a couple of patterns, you can solve it pretty quickly. Okay, we have two triangles here, right? And they are both right triangle, or right triangles. And how do we know this? Well, in the question, it says that line L is perpendicular to line, parallel to line M. And then segment BD is perpendicular to line M. If it's perpendicular to line M and L and M are perpendicular, then that means that BD is also perpendicular to L on both sides. So we know that triangle ADE is a right triangle because it has a perpendicular angle. And already we see, oh, they give us the side length of DE over here. It's 5, and then the side length of AD over here, we can use the Pythagorean theorem to find the value, the side length of AE. And just to clarify, they ask, what is the length of segment AB? And let me use a different color. Yeah, what is this length of segment AC? So that means we need to find the length of AE, and we need to find the length of EC. And we'll get to that. For now, AE, yeah, it should be pretty simple. C squared, like we'll label this as C. C squared is equal to 5 squared plus 12 squared. And this is equal to 25 plus 144, which is equal to 169. So C squared is equal to 169. If we square root both sides using a trusty calculator, you should get C is equal to 13. So, okay, congratulations. We know that AE's side length is 13. Now we have to find EB, the length of EC based on triangle EBC. Now, the thing about triangle EBC, I'll use a different color for that. Triangle EBC is that EBC is related to triangle ADE. So you see what I said over here? Two triangles are similar if they have the same angle measurements. What similar means is that they're essentially the same exact triangle, except one is just bigger than the other. An example of this, if I have a triangle with side lengths 1, 1, 2, and then I have another triangle with side lengths 2, 2, 4, these are both actually the same exact triangle because if you notice, all the side lengths of the second triangle are just the side lengths of the first triangle, but doubled. And another thing is that similar triangles always have the same angle measurements to each other. So this angle corresponds to that angle, this angle corresponds to that angle, and this right angle obviously corresponds to the other right angle. So in this case, how do we know that, oh, whoops, didn't mean to clear the whole thing, but yeah, how do we know that these two angles are similar to each other, which is important for the question? Well, we know that because if we use our angle laws from before, remember, if they have the same angle measurements, they are congruent. Well, you see how these two angles are opposite to each other? So this angle is going to be corresponding, or it's going to be congruent to that angle over there. So we have similar angles over there. And then remember alternate interior angles? This is an interior angle over here. And then it's an angle A is an interior angle, and C is alternate to A because they're on different sides of the transversal, and it's also interior. So C is congruent to A. So, okay, basically EDC is congruent, sorry, not congruent, is similar to ADE. And we can find the value of EC based off of how big EBC is. But how do we know how proportionally smaller EBC is? Well, look over here. They give us the height of segment EB, which is 1, and EB corresponds to DE. And okay, DE is 5 units, whereas EB is 1 unit. So DE is 5 times greater than 1, right? So EBC is, sorry, or ADE, triangle ADE is 5 times greater than EBC. So we can apply that to the length as well. We can create like a small proportion actually, where, let's see. Okay, we have EC, which corresponds to AE, and then EC, okay, corresponds to 1, and then AE corresponds to 5. The way this works is you can take 2 line segments from 2 similar triangle, in this case EC and AE, and then you set them equal to the proportion that represents their size difference. In this case, we know for a fact that EC is 1 unit and AE is representative of 5 units, which means that triangle ADE is 5 times bigger than EC, right? And we know the value of AE, which is 13. So EC, if we solve the equation, we get that EC is equal to 13 over 5. And then we know that the length of segment AC is equal to 13 plus 13 over 5. That obviously has a decimal equation, but yeah, we'll just leave it at that. So, okay, I assume this might, okay, does anyone have any questions at the moment? Okay, well, it doesn't seem like we have any questions, which I'm a little bit surprised about, but we'll continue on. Okay, another topic is isosceles triangles. So the definition of an isosceles triangle is a triangle that has 2 congruent side lengths. What that means is basically it's a triangle where 2 of the sides have the same length as each other. So an example would be if you had this triangle, it had side length A over here, side length A over here, and then side length B down there. And clearly AA are equal to each other. Another quality of isosceles triangles is that the corresponding angles have the same congruent features, where when I say that an angle is corresponding to a side, I'll show you what I mean. Let's label each of the points here, okay? This is angle A, that's angle B, this is angle C. I'm saying that this side corresponds to that angle, and then this side corresponds to angle C. And you see, you notice how AB or okay, like yeah. side AB, it has the same length as BC, that means that their corresponding angles also have the same angle sizes. So if AB is equal to BC, then angle A is equal to angle C. Now, this is going to be helpful here because let's take a look at this. In the figure above, we have a regular polygon with the 9 sides. It's been divided into 9 congruent isosceles triangles by line segments drawn from the center of the polygon to its vertices. What is the value of x? We have to find the value of x over here, okay? Now, if you notice here, this is a polygon, right? And okay, how are we supposed to find x? We don't know any other values, and we don't know the value of the other angle. So we need to try and find the value of the central angle that is not similar to the other angles up here. Maybe that'll help us. Well, common bit of information is that if you go full circle, that equals 360 degrees, right? Well, they're going full circle here, if you notice. And there are 9 angles, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 360 degrees is distributed between all 9 of those core angles. So we just do 360 divided by 9, and we know that the interior angle is equal to 40 because, well, 360 divided by 9 is 40. So the value of this angle is going to be 40 degrees. Another important piece of information is that triangles, their total angle, the sum of all the angles in a triangle is equal to 180 degrees. So if you did angle A plus B plus C, it would all equal to 180 degrees, no matter how wide some of the other angles can be. Even if you have like a super duper obtuse triangle like this that has a massive wide angle over there, you notice how the other angles in turn are also very small, it adds up to 180 no matter how you slice it. So yeah, okay. That means we know that 180 is equal to 40 plus, let's just label these angles as A and B. And we know that angles A is equal to B because these are isosceles triangles, right? And that means that the 2 angles that correspond to the isosceles sides are congruent. So if A is equal to B, we can just say that this angle over here is also considered A. And then we can say 180 is equal to 40 plus 2A. And then we subtract 40 from both sides. We get 140 is equal to 2A. And then we get A is equal to 70. So therefore, x degrees is equal to 70 degrees. Are there any questions? All right, nope, doesn't seem like there are. Okay, now another important concept is special triangles. So in trigonometry, there's 2 main triangles that have special properties depending on the values of their angles. So the first one we're going to talk about is the 90, 45, sorry, not 44, 45, the 90, 45, 45 triangle. And as implies, it's basically a triangle that has a 90-degree angle and 2 45-degree angles. And the special property is that the special property of special triangles is that if you know that a triangle has these values, you can easily find the side lengths of this triangle if you know the value of one of the side lengths. In this case, the side lengths are going to be 1, 1, and root 2. And you notice how the corresponding the angles that correspond to their respective sides, you notice how these 2 sides are congruent to each other and their corresponding angles are also congruent to each other. Another example of how congruent and corresponding are related to each other. And also the 90-degree angle corresponds to its own side, There is a pattern here actually, which is that the bigger the angle that a side is corresponded to, the larger that side is going to be. For example, if you have an obtuse triangle over here, this is like the largest angle. Let's say angle A, it corresponds to this side. Let's label that as lowercase a. A is going to be the biggest side because it corresponds to the biggest angle. Okay, we're getting ahead of ourselves here. Let's focus back on the question. Okay, so how is this useful? Well, let's say, first of all, don't think of these side lengths as side lengths. Think of them as proportions. I'll explain what I mean. If you have a triangle that you know is 90, 45, 45, and then you see that, oh, the side lengths of one of the short sides is 3, you can easily find the side length of the hypotenuse over here because the short side lengths correspond to a value of 1, while the hypotenuse corresponds to a value of √2. You can create, well, a proportion that represents, okay, 1 over √2. This is the small 1. This is the hypotenuse. It's equal to, we know that the short side has a value of 3, and then we know the hypotenuse, we don't know the hypotenuse yet. If we solve the proportion, we get y is equal to 3√2. And obviously you can see, oh, it's pretty simple. You know, we just multiplied 3 by √2 and we easily found the value of y. And the next one is slightly more complicated. It's a 30, 60, 90 triangle. Oh yeah, I wanted to, it's just a small mistake, but they don't refer to it as a 90, 45, 45. They refer to it as a 45, 45, 90 triangle. But yeah. Okay, so in this case, the proportion is going to be the largest right angle is going to correspond to a proportional value of 2. The 60-degree angle is going to correspond to the second largest value of √3. By the way, if you're curious, √2 corresponds to around 1.4, and √3 corresponds to around 1.7. But yeah, anyway. And then the smallest angle corresponds to the smallest value of 1. So in this case, if you had a triangle like, say, it doesn't look like 3060. Let me draw a better one. Get a 3060 triangle, and let's say the hypotenuse, we knew that the hypotenuse's length was 4, and we want to find the length of the second largest. Let's say this is the 60-degree angle, so it corresponds to the second largest side. We want to find the value of the second largest side length. Then we can set up a proportion where, okay, we know that the second largest side length that corresponds to a 60-degree angle has a proportional value of √3. So √3 over, what is it? Okay, 2, because we know the value of the hypotenuse, which has a correlational value of 2. And then it's equal to a over 4. If we solve this, we'll get 2 to the root of 3. Or yeah, we should get to, I'm just checking my math. Yeah, 2 to the root of 3. So yeah, we know that that's the length of side A. So that's how special triangles are useful. I won't dwell on them any longer. Instead, we'll do some practice. I'm going to give you guys 2 minutes to do these questions starting now. All right, everybody, 2 minutes are up, so let's come back and check out these questions. All right, first triangle, it's a 45, 45, 90 triangle. The hypotenuse corresponds to √2. The short side corresponds to 1. So let's set up our portion, root 2 over 1 equal to 3 over a. A is equal to 3 root 2. Pretty obvious as well. You can just do 3 times root 2 and it'll be easy. It's since like, the short side is equal to a value of 1. Okay, the next triangle, 30, 60, 90 triangle, find the measurement of x. Okay, x corresponds to the shortest angle, and the shortest angle corresponds to a side length of 1. And then this is root 3, if we remember correctly, and this is going to be 2. Oh, wait, no, that's wrong. It's going to be 2, and this is going to be root 3 down there, because 60 corresponds to root 3. But yeah, okay, so we have our proportional values. So let's set it up. 1 over root 3 is equal to 3 over, is equal to x over 3. And then we get x is equal to 3 over root 3. Now you might think this is the answer, but we can actually simplify it a little bit more because it's 3 over root 3, right? Well, if you think about it, root 3 squared is equal to 3, right? Root 3 times root 3. So if we do root 3 times root 3 over root 3, the root 3 is one of them on top and the one on the bottom cancel out, and we end up with the value of root 3. So actually, the correct answer is going to be x is equal to root 3. Yeah, it's like a small tidbit. Actually, if you get any sort of answer, which is like the square root of like some value over that value. Oh, wait, no. It's the reverse, actually. If you get some value over the square root of that value, it's going to be equal to the square root of that value. Seems a little bit weird, but it's true. Okay, the next one, 45, 45, 90 triangle. Okay, what is the value of side A? Okay, it should be pretty simple. In fact, we can just skip ahead and just do root 8 times root 2. If you know, when it comes to roots, you can multiply the terms inside of them. So you get root 16, which is equal to 4. All right. Any questions? All right, doesn't look like there's any, so let's move on. Okay, so these are some complicated word problems. I'm just thinking whether or not. Okay, yeah, we'll go over the first one because it's a real brain bender. I want you guys to think about this question for 2 minutes, and we'll come back and we'll see how to solve it. But yeah, you're not pressured to solve this question. Just think about how you can approach it. Think about what things you have to subtract from each other. All right, everybody, 2 minutes have passed. Let's come back and check out this question. All right, so when it comes to super big problems like this, the first thing that I suggest is trying to gather as much information as you can and try and put it on the question or display it if you can. So, okay, O is the center of the circle. Segment BC is tangent to the circle at B. For those who don't know, tangent means that it just barely touches the circle at just one point. And an important thing about tangents with circles is that they are perpendicular to the line that forms between the point they are tangent to and the center. So this would be tangent over here. And since they say BC is tangent to the circle, we can say that this angle over here is a right angle. So that means that this is a right triangle. Now, okay, what's the next bit of information to give? OB is equal to AC, which is equal to 6. So, okay, OB is equal to 6, AC is equal to 6. Now, okay, you might not have noticed this, but you see how OB, it starts from the center and it goes to the edge? Doesn't that mean it's kind of a radial length? Like, this is literally the radius, right? So if OB is a radius, and then we know that the radius is 6, which is actually helpful because look over here. OA is also a radial value, goes from the center all the way to the edge of the circle. And if we know the radius is 6, that means OA is also 6. That means that the side length of this whole hypotenuse over here is 12. And if you remember, the important thing is that this is actually a special triangle, because if you notice, this is 6 and this is 12. Those are the side lengths, right? That corresponds to the same proportions of a 30, 60, 90 triangle, where it's, remember, it's 1, root 3, and then 2. This, in this case, is the 2, and the 6 is the 1 in this case. So we know that this is a 60-degree angle, and then this is a 30-degree angle, which is actually going to be helpful as well. And if we know the side lengths of BO and OC, we can find the side length of BC, this one over here, by simply doing, let's just choose the hypotenuse, and we'll label the, okay, yeah, so BC over 12 is equal to root 3, that was an awful root 3 over 2. So BC is equal to 6 to the power root 3, right? And then next, they ask, what is the area of the shaded region? Okay, so how do we find area of the shaded region? Well, okay, if we clear everything just for a second, and we keep the important bits of information, the important bits is that this is a radius of 6, or a side length of 6, and this is 6 root 3 over here. We need to do this triangle, right? We need to find the area of this triangle, and then we need to find the area of this circular segment, and we need to do triangle minus the circular segment, right? So let's find the triangle first. That's actually going to be pretty simple because, well, we have the height over here and we have the length. So the area of the triangle is half times base times height. So that's going to be equal to 18 root 3. And if you look at the options below, you see how they're all structured in like a sort of something root minus something pi. This represents the triangle, and this represents the circle. So immediately we can eliminate C and D because they have the wrong triangle values. Oh wait, didn't mean to clear everything. But yeah, as I was saying, okay, so we know the value of the triangle. Now let's find the area of the circle segment. Now, how do we find the area of the circle segment? Okay, so the area of a circle is equal to pi r squared, if you didn't know that. And we know that the radius is 6, so the total area of the circle is going to be 36 pi. But how do we find the area of the segment of the circle? This 60-degree segment, oh wait, it's 60 degrees, right? Remember how a circle, it goes a full 360 degrees? So if you took like a segment of the circle that is only 60 degrees, well, 60 divided by 360 is equal to 1/6, right? So we can say that the 60-degree portion of the circle is, well, a sixth of the circle. So we can actually take the area of the whole circle and multiply it by 1/6, and we'll get the area of the segment. So in this case, the area is going to be 6 pi. So then if we subtract those two, we get 18 root 3 minus 6 pi, and B is going to be the correct answer. All right, seems I have some questions. Avanish, you have a question?
Yeah, but like, can you? We don't know the angle is 60 degrees, low. Like, so how are we supposed to find out the area of the segment?
Oh, if you remember, we do know that the angle is 60 degrees because if you remember, we figured out that the length of line OC is 12 because this is 6 over here, and then AC is also 6. And if you remember the special triangle rules of the 60, 30, 90 triangle, which is 1, root 3, and 2, you can use a special triangle rule in reverse where if you notice a pattern
No, no, no,
of
no.
two sides.
I may be wrong, but I think you might be confused with the triangle. I'm asking like, how do we find the area of the semicircle, not the area of the segment of the circle?
Oh, okay. So the area of the semicircle. Well, if you think about it, a full circle, it goes 360 degrees, right? So if we take a 60-degree portion of that, that's equal to 1/6 of the full circle. So it's pretty simple, actually. You can just do the value, you can just do the area of the whole circle multiplied by 1/6, and you'll get the area of that segment. If you want something more concrete, you can say area of the circle times x degrees over 360. And this represents the size of the segment. For example, if the size of the angle was 90 degrees, so you had a circle and you had a 90-degree angle, you can kind of see obviously that's equal to 1/4 of the circle, like if you were cutting it like a pie. But that would also apply here, where you substitute 90 degrees into the x, and it would equal to 1/4 over
Wait,
there, this part.
but to find out, what do you see? But to find out the segment, we need an angle, right?
Oh, you mean are you talking about
This
the length of BA?
not yeah, no, the angle of BA.
The angle of BA?
Yes,
Well, yeah, well,
you told 60, but
okay.
60 isn't given.
Yeah, it's not given, but we discover that by using the triangle rules.
Oh,
Yeah, apologies. This is like a really complicated
okay.
question. If you'd like, you can review the video and maybe that'll clarify it.
Oh, okay. Thank you.
Unfortunately, since we don't have much time, we're gonna have to move on. I know some people probably have more questions, but we have to move on. Okay, we're not gonna do this yet. I'll probably save it for later. All right, here is a quiz. I'm not exactly sure why I call this a mini quiz because it's far bigger than mini, but yeah, I will give you how much time? I'll give you 4 minutes to do this starting now. All right, everybody. 4 minutes are up, so let's come back and check out these questions. Okay, oh wait. All right, let me go back to okay. So the first question, we have a hexagon, 6 equilateral triangles. Oh, whoops, I think I forgot to explain equilateral triangles. For those who don't know, an equilateral triangle is basically a triangle that has 3 congruent sides and 3 congruent angles, which is going to be 60-degree angles. Simple as that. They ask, find the value of the measure of angle x. Well, okay, it's already kind of a dead giveaway. If it's an equilateral triangle, it's going to be 60 degrees. Okay. The next question, we'll move on to a separate slide to do that. In the figure pointed above, point B lies on line AD. What is the value of 3x? So we need to find the value of x. Okay, yeah, this should be pretty simple actually. We know that CB is perpendicular to line AD. Why? Because there's a 90-degree angle over there. That means that the angle on the other side is also 90 degrees. And all we have to do is, these are all angle segments that clearly add up into one angle. Excuse me. We just do, all right, x plus 2x plus 2x, that's 5x. 5x is equal to 90 degrees. Therefore, x is equal to 18. And then they ask for 3x. 3x is equal to 54. So the correct answer is going to be C. All right, the next question. In the figure above, AD intersects BE at C. If x is equal to 100, what is the value of y? So what is the value of this angle? Now, yeah, remember that total angle sum is equal to 180 degrees for triangles. In this case, okay, we have x and we have y. Okay, so we already know that, you see how these two angles are made from two lines that are intersecting each other? These are opposite angles. And remember what I said about opposite angles? They are congruent to each other. So that's helpful. We'll just label them as A since we don't know for sure what they are yet. But, all right, let me think through that a little bit. Okay, if x is equal to 100, oh, okay, so they give us the value of x right out of the gate. So 100 degrees. So we have 20 plus 100 plus A is equal to 180 degrees. A is equal to 60 from that. So we get 60 degrees for angle, that angle right there. And since these two angles are congruent, we get 60 over here. And oh, look at that. We get what we can do, y plus 60 plus 40 is equal to 180. And we'll solve for y is equal to 80. So C is the correct answer here. Okay, the next two questions. Next one, a little bit slightly more challenging. They ask us to find the measure of angle B, which is a little bit tough since this is a quadrilateral shape or quadrilateral polygon, not triangle. But one thing we can do is, on the ACT, you can actually, well, you can obviously draw on the question, you can draw on the paper. A helpful thing when it comes to geometry is drawing lines and making up scenarios. In this case, try and think, what if we had a line that goes from B to AD perpendicularly? Like that. Like imagine there's a line just like that. And if it's perpendicular to CD, or sorry, if it's perpendicular to line AD, then obviously these two lines, they're going to have the same height values, right? Because they are perpendicular to the same line. And if it's perpendicular to line AD, and AD is parallel to line BC, then okay, it's a perpendicular line up there. And yeah, basically all the signs are pointing to those two values being the exact same. And the cool part is that, okay, if we created a system like this, then we know that we can split it into two angles. We can split B into two angles, this angle over here and this angle over here. And we already know the value of that angle on the right side since it's a perpendicular angle, 90 degrees. Oh yeah, that should have been like a dead giveaway that D is the wrong answer because visually you can see the angle B is much larger than a perpendicular angle. I also want to say that relying on visuals for geometry is not always helpful though, because sometimes the angles won't be drawn to scale. You can't say that oh, this angle B, it looks like it's 120 or it looks like it's 135. Therefore, it's got to be that answer. Sometimes they might purposely draw it slightly off scale to trick you because they want you to do it purely mathematically. Now, they said that CD is equal to half of AB. So if CD is equal to half of AB, well, what side length did we give CD? We gave CD A. So A is equal to 1/2 of AB. That means that 2A is equal to AB. So we can put a value of 2A there. Oh, would you look at that? We have a special triangle pattern over here. A and 2A, that corresponds to a 30, 60, 90 triangle, remember? And in this case, it's going to be 1 root 3, 2. So we can actually use this and say, okay, if this is the hypotenuse, which corresponds to the right angle, and this is A, we know, is the smallest side in this case, and the smallest side corresponds to the 30-degree angle. So this has got to be 30 degrees. And what's left? We have 60 degrees right there. Then we can do 60 plus 90, and that'll be equal to 150. So A is going to be the correct answer. Vijay, you have a question?
Yeah, how did we know that the hypotenuse was 2A?
Oh, because this bit of information here helped us figure that out. CD is equal practice. We'll move on to some practice to help you understand this. So using the information that I just told you, I want you to find state the vertex and radius of the circles created by the function for the first two, and then apologies, I forgot to put it in black. I forgot to put it in white, but the two questions down here where I'm asking you to write the function of the circle are there. So, okay, I'm gonna give you guys 4 minutes to do these problems. Admittedly, since you're just starting, you probably won't finish. In that case, we'll clean up the last two problems likely together. All right, everybody, 4 minutes are up, so let's come back and check out these questions. So the first ones are actually relatively simple. The vertex, like I said, you just set these two equations equal to 0, and then you take the values that you get for x and y, and that's your vertex. So the vertex is going to be negative 49, comma 28, and then the radius is equal to the square root of that value you see on the end. That's just going to be 9. For this one over here, it's going to be 13, comma negative 3, and then square root of 49 is equal to 7. Okay, now I say write the function of the circle drawn above. So, okay, first order of business is finding the radius. That's actually pretty easy. You know, you just draw a line from the topmost to the bottommost point, and you find the area where they are directly. You cut that line in half, and you see what the value of that line is. You see the length of that half, and that's your radius. In this case, the length of the radius is going to be 1. So r is equal to 1. And then, okay, what is the origin? The origin is going to be, well, directly in the center. You can kind of eyeball it in this case. It's going to be what? 1 comma negative 2. 1 comma negative 2. So we're going to have to go reverse where, okay, x minus 1 squared, because we have an origin value of 1. So we have to make sure that whatever, x minus something value we put, that the result is going to be 0. In this case, 1 minus 1 is equal to 0. So x minus 1 squared plus y plus 2 squared is equal to 1, because, well, the radius is 1, and 1 squared is just equal to 1, right? All right, next one, the origin is going to be located right there. The radius is going to be, how much is that? We start at 5. It's going to be 1, 2. The radius is going to be equal to 2. And then the origin, we just determined it's right over there. The coordinate is going to be 0, comma 5. In this case, since the x coordinate or for the origin is going to be 0, we just write x squared plus y minus 5 squared is equal to 4, because 2 to the power of 2 or 2 squared is equal to 4. All right, are there any questions? Doesn't seem like it, so let's move on. Okay, now here is a word problem dealing with circular functions. Okay, they say the graph of a given equation in the xy plane is a circle. Yeah, that's a circle, all right? If the center of the circle is translated 1 unit up and the radius is increased by 1, which of the following is an equation of the resulting circle? So basically they're saying, if we take this, the circle that corresponds to this equation, and we make it go up by 1, in other words, we increase the y value of the origin by 1, and the radius is increased by 1, what is the equation of the resulting circle? First of all, let's get the information that we know from the original circle. So we know the radius is equal to 2 because square root of 4 is equal to 2, obviously. And the origin is going to be 0, comma, -1. Now, if we increase the radius by 1, that's going to be equal to 3. And then if we translate the circle 1 unit up, that means that the y value is increasing by 1. We get a new origin of 0, comma, 0. So what equation does that give us? X squared. We can just leave it as x squared because there's no, it's just at the center, right? X squared plus y squared is equal to 9. Therefore, B is going to be the correct answer. Some common mistakes you might have done is, doing 1 unit down instead of 1 unit up, in which case you would answer probably D. Another mistake is when they say increase the radius by 1, you would have simply just done 4 plus 1, and you might have done A by accident. For those of you who are confused about the origin, yeah, the origin is 0, comma 0. That's why B is the correct answer. Okay, next question. This one's gonna be a little bit tricky to grasp your head around, but we should be able to do it. Okay, the graph of the equation above in the xy plane is a circle. What is the radius of the circle? So you might think, oh, okay, that's a pretty ugly number, but we have to do it. What's the square root of 24? Nope, don't do that yet, because if you notice over here, this is not a complete circular function. Look at how this is, clearly you look at it, it looks nothing like this clean function over here. So what we need to do is, excuse me, we need to take the x portion and the y portion over here, and we need to complete them. Now, what does completing mean? So the concept you need to understand is, okay, if you have an equation like x plus y, actually, no, let me use a and b since that's a little bit easier. If you have a plus b squared, that is going to be equal to a squared plus 2ab plus b squared. It's a pretty simple thing that pretty much everyone knows. Now, the thing is that you can actually do a thing called completing the equation, where let's say you are given a part of a quadratic equation where you have an equation of y is equal to a squared plus 2ab, like just that. What you can do is, in order to make it easier for yourself, you can say, okay, let us add the b squared by ourselves. Excuse me. But to compensate, we also subtract b squared. So we're just doing b squared minus b squared, which is technically equal to 0. But in this case, we add the b squared into our original equation over here, and we end up with y is equal to a plus b squared minus b squared. Now, obviously, this seems a little bit redundant at first. How would this ever be useful? I'll show you. In the first part over here, x squared plus 8x up there, I'll use a different color, x squared plus 8x. We can tell that, okay, 8x is equal to 2ab, right? In this case, a is equal to x. So 8x is equal to 2xb. That means b has to be equal to 4, right? So the b squared value is going to be 16. We can do plus 16 minus 16 and turn this into x plus 4 squared minus 16. So we created a full quadratic equation that actually can be used in a circular function. Now we have to do the same thing for the y. I'll use a different color. Okay, for the y squared minus 6y. Okay, negative 6y is equal to 2 ab, so the a is equal to y in this case, and negative 6y is equal to 2y. b, therefore b is equal to negative 3, and then b squared is equal to 9. So we have to do plus 9 minus 9, which turns into y minus 3 squared minus 9. Yeah, it should be y minus 3, yes. So, okay, we took these two equations and we turned them into more circular function appropriate equations. So I'm just going to erase this red part over here so that we have some space to work with. We have these two parts over here, right? Let's add them all up. So x plus 4 squared minus 16 plus y minus 3 squared minus 9 is equal to 24. Now, in order to get into circular function form, we have to get rid of all the constants on the left side. Plus 16 plus 9, and then we add plus 16 plus 9 to both sides. What do we get? We get x plus 4 squared plus y minus 3 squared is equal to 49. Now look at that. That is a beautiful circular function, and crazy as it seems, it is exactly equal to the function that you see up there. It is completely equal. They're basically the same thing, except now it's actually usable. We know what the x-coordinate origin is. We know what the y values or coordinate origin is, and we know what the radius is. What is square root of 49? It's 7. So that is the correct answer. And that is overall how completing a function works. Unfortunately, I am getting requests to re-explain some things. Unfortunately, since we don't have a lot of time, we do have to move a little bit quickly, so sorry. If you'd like, you can check the recording that will be posted up at a later time. Okay, so here is a mini quiz. All right, I am gonna change my mind a little bit and say that you don't have to do the first question since I find it kind of redundant. So for now, just do the other two questions, the other three questions, and I'll give you guys 2 minutes to work on those starting now. All right, everybody. 2 minutes are up, so let's come back and check out these questions. Okay, so just to make sure. Okay, yeah, so I did post separate slides for analyzing these questions, so I'll just do that. All right, so for the first question, okay, which of the following functions is representative of the circle above? Okay, well, where's the origin located? It's located at -3, comma 3. So either it's got to be either, wait, no, it's got to be either, what is it? Yeah, so we know for sure that it definitely can't be C because it has the wrong origin values. Now, what is the radius? Okay, well, 1, 2. Okay, the radius is 2. So that means that r squared is equal to 4, and therefore the correct answer is going to be B. Okay, now for the next question, this is going to be completing the function question. Thankfully, you only have to do it for the y portion. Let's complete the y function. Excuse me. Y squared minus 8y. Okay, 2ab is equal to -8y. In this case, a is equal to y. So 2yb is equal to -8y. B is equal to -4. So then b squared is equal to 16. We have to do plus 16 minus 16. We end up with y minus 4 squared minus 16. So if we combine that with the original equation, x plus 5 squared plus y minus 4 squared, and then we have the minus 16 over here, minus 16, which is equal to 9. We can add 16 to both sides and we'll get 25. This is our r squared, and therefore r is equal to 5. Okay, now the next one is a translation question. The graph of the given function is a circle. If the circle was translated 1 unit to the left and 2 units down, it has its radius decreased by 5. Which of the following functions is representative of that circle? They give us a whole bunch of different stuff. Let us find the original details of the original circle first. So the origin is going to be, what is that, x minus 1 and y. Origin is going to be 1, 0. The radius is going to be equal to 9. So, okay, if the circle is translated 1 unit to the left, so 1 unit to the left means -1, so x. So x is decreasing by 1, and then the y is going 2 units down, so y is decreasing by 2, and the radius is decreasing by 5. What is our final detail, or what are our final results? 1 minus 1 is equal to 0. The x coordinate is going to be 0 for the origin, and then 0 minus 2, that's going to be -2. And then for radius, 9 minus 5 is going to be 4. Radius is going to be equal to 4. So, okay, we know for a fact it's got to be either C or D because A and B have the wrong radial values. For C is going to be wrong because it has an x value that is not 0 for the origin. Therefore, D is going to be the correct answer because it has x coordinate representing 0 and a y coordinate representing -2. Are there any questions? All right, doesn't seem like it, so let's move on. Okay, so trigonometric functions. Oh boy, let's see how many slides they actually have. Wow, okay, that is a whole lot. So, yeah, okay, I think we can get started on this. Trigonometric functions are relatively complicated. They are a calculator function. Okay, I'm gonna say this. If you don't know how to do trigonometric functions, then unfortunately we're not going to have time to explain them right now from scratch because we have 10 minutes left. So I highly suggest that you go online and find a resource that can teach you how to use trigonometric functions. You just search up trigonometric functions and you should be good to go. For now, we'll move into how to use a trigonometric function. So trigonometric functions are used for right triangles, and primarily they are used to find the side lengths or angles of a triangle. So actually, you know what? Since we do have time, I might as well just explain them anyways. With trigonometric functions, there are three types of functions. There's sine, cosine, and tangent. And each of them correspond to a different proportion of sides. So sine corresponds to opposite over hypotenuse, and cosine corresponds to adjacent over hypotenuse, and tangent corresponds to opposite over adjacent. It takes a little bit of time to memorize. You have to memorize this acronym called SOHCAHTOA. Another note is these functions are dependent on the angle that you use. Let me explain. So if you do sine of x, this x represents the degree value of the angle you are analyzing. So in this case, we have angle A over here. Let's say we did sine of A. So the sine of A, what does sine represent? It represents opposite over hypotenuse. Opposite means the angle that is directly opposite to that angle that we're analyzing. Adjacent means the side that is directly next to the angle we are analyzing. And hypotenuse means, well, the hypotenuse, which is the longest side. For clarification, yes, the hypotenuse is technically adjacent to the angle, but it has its own classification. So hypotenuse is basically the side that is next to the angle that is not the hypotenuse. In this case, the side length of 4 over here. But back to talking about sine. Sine is equal to opposite over hypotenuse, right? In this case, the opposite side value is going to be 3, and the hypotenuse side value is going to be 5. So sine of A is equal to 3 over 5. And for cosine of A, it's something similar where it's adjacent over hypotenuse. The adjacent value is going to be 4, and same hypotenuse value, so it's going to be 4 over 5. And same thing for tangent, which is opposite over adjacent. Okay, so let's move on to how to actually use these. This is something you absolutely need a calculator to do, FYI. So, okay, there's two ways you can use trig functions. One is if you have a triangle where you know the angles, but you don't know one of the sides. So you set up a system that involves the unknown side. That is how you use a trig function. For example, okay, we know that the angle over here is going to be 40 because the 90-degree angle, and that is 50 degrees, and we don't know the value of this side over here. So all the functions you see up above are trigonometric functions that involve the x value. In this case, let's choose this one, sine of 50. So sine of 50, this means we are talking with respect to this angle. So sine of 50 is equal to opposite over hypotenuse. Now, what is the opposite value? Opposite means opposite to the angle we are analyzing. So in this case, the opposite value is going to be x. X over hypotenuse, which is 10. So yeah, we get sine of 50 is equal to x over 10. And then in this case, what you need to do is you need to get your calculator out and you have to input the trigonometric function sine of 50. If you do sine of 50, it'll return a number value to you. Honestly, don't think of trigonometric function as some kind of weird arcane mathematical concept that is difficult to understand. Just think of them as functions. You plug a number into a sine function, a cosine function, a tangent function, it'll return something back to you. Simple as that. So we do sine of 50. We plug sine of 50 into our calculators. It might be a different depending on what calculator you use, if you have a scientific or graphing. But in this case, sine of 50 is equal to 0.76604. And then we simply solve this equation over here, and we get x is equal to 7.66. Yes. And if you want to check, you can do the Pythagorean theorem just to confirm. Like, I'll do it right now. 16 plus 7.66 squared. Okay, well, it seems like something is not exactly right on my end. There might be a calculator setting amiss. But yeah, that's basically how you use a trigonometric function if you don't know one of the side lengths. Now, for using the trigonometric function, if you don't know an angle, a little bit more complicated. You have to set up the system as usual with respect to the angle that you don't know. So for example, tangent of x is equal to 5/12. So that is what? Adjacent over opposite. So tangent of x is equal to 5/12. What we need to do is we need to isolate x. But how do we isolate x? Now, there's this thing called inverse functions on your calculator. You typically access them by pressing the second button. It's literally a button called second or maybe alpha on your calculator. It's usually at the top left corner. You press second and you press the corresponding trigonometric function button. And instead of getting tangent, you'll get tangent to the -1. And this is what we call an inverse function. Basically, when you take a function and you literally move it to the other side, you have to change it to an inverse function like this. And then all you have to do is simply calculate x is equal to tangent inverse function of 5/12. So if we do that right now, we should get an x value of 22.62 degrees. So, okay, that's pretty much how you use trigonometric inverse functions. Okay, seems like we are out of time. So unfortunately, that is where we are going to stop for today. Now, okay, a little bit update on how the course is currently going. Since the core math portion is literally almost done, we only have like 6 more slides to go. I'll consider releasing the last 6 slides as an open slideshow that you guys can access and learn from so that we can move on to writing next class. That's currently how it's going. I'll let you guys know if maybe instead we'll continue on and then we'll transition into writing in the middle of the class. But yeah, that's pretty much all I have to say. Once again, thank you for coming. If you have any general questions about the ACT, then you can stay back and ask me them. But yeah, that's all I have for you guys for today, and I'll see you on Tuesday.
Are the SAT and ACT formatted similar?
They are, well, the content is similar, save for the science section, but no, they're formatted significantly differently, actually. ACT is much faster, and stuff like that. Actually, that's pretty much the only difference. In terms of like just general question format, like how they ask the questions, yeah, they are pretty similar in that vein, but they definitely feel different.
What do colleges prefer more, ACT or SAT score?
Colleges don't prefer one test over the other. They're both equally good.
So, it doesn't matter either if I take SAT or ACT.
Nope, you can take whichever one you'd like. Some people they take both of them and they submit the best score they have. Some people take both of them and they submit both of the scores to the colleges. That's what I did.
What's more beneficial?
For me personally, even though I did both exams and I submitted both of them to the college, I don't believe that it helped me in a great way to do both of them. I think it's better to focus on one exam and do extremely good on that exam in particular. Of course, if you feel like you're up to it, then by all means, you can try to do both exams and submit both of them to the college.
So, the practice for both of them is similar, or is it different?
There are plenty of practice exams online that you can just search up. The practice exams, they're definitely going to feel different. The SAT, it feels different to take an SAT compared to an ACT. But in terms of the actual content, like the SAT and ACT will both have the same math content, like Algebra 1, Geometry, Algebra 2, trigonometry, etc. The writing content and reading content is also relatively similar. It's just that the ACT does it a little bit faster in terms of time. And the ACT also has a science section, which is basically data analysis. So yeah, content is similar, but speed and general vibe of the exam is going to be different. And same thing applies to the practice.
So
For
both the SAT and ACT are both like timed, right?
Yeah, they're both times.
And then there's a science section for the ACT.
Yeah, the ACT has a science section. It's not really a science section. It's kind of like a second reading section, to be honest. We'll go over it much later in the program, but yeah, it's no big deal.
Okay, thank you.
No problem. All right, doesn't seem like there's any other. Oh,
So
yeah, do you have a question?
yeah. So, if I take the SAT and I score good, if I take the SAT score and go good, and if I take the ACT and score good, what's the what like outcome is that?
If you do good on both of them, I would suggest that you submit both of the exams to the university during your application process. If you do better on one exam than the other, you can opt to not send the other score, the score that you did worse on, so that you can have the best score shown only to them. But yeah, if you do like equally good on both of them, then by all means you can send both of them.
All right, thank you.
Okay. Yep.
And
No
one more
problem.
thing. The essay part, what is the essay part graded on?
Okay, the essay part is something that we're not covering in this program. As far as I'm aware, the SAT is getting rid of its essay and the ACT is keeping its essay. From what I've heard, the essay is losing importance, but if you want to know, the essay is basically a situation where they give you a writing prompt and you simply write an essay on that prompt where it's like they ask you a question and you have to develop an argument and you have to defend your argument. It's very open-ended.
Oh. All right, thank you
Yep.
so much.
No problem. All right, then we'll have a good night, you guys. Bye.